Hello everyone, so I'm Chandra Shekhar from IT Indore, and I'm going to be talking about the impact of Lightcone effect on C2 and H1 21 centimeter signal statistics from the EoR. So as as we are interested in let's say the evolution of the universe, and particularly during the period when the early galaxies started emitting ionizing radiation, which eventually changed the state of the IGEM. So the question we'd like to ask is that how did this process of reaction happen? And therefore, it leads us to the question that how do we actually probe EoR? So we can use some intensity mapping techniques such as the 21 centimeter signal, so that originates from neutral hydrogen, and therefore it is a very excellent probe of the evolving state of the IGM from EoR. Similarly, among some other line emissions from star-forming galaxies that were responsible for radiation, we can use one of them, which is the C2 line emission, which occurs at a wavelength of 158 micrometers. So this is a very excellent probe of the galaxies that were responsible for the radiation. So now to observe these signals, we have to deal with something called the Lightcone effect. So which essentially means that since the radiation has a finite travel time, so if we are observing a signal across the line of sight, so if let's say two slices are separated along the line of sight with a certain distance, then the signals must have emerged from these two slices at two different times such that they can reach to us at the present time. So it means that we'll be observing the signal something like this, where we would see the universe continuously evolving across the cosmic time. And this phenomenon, which is known as the Lightcone effect, can significantly impact the statistics such as the power spectrum or cross-pow spectrum that we are interested in. And this is what we do in our study to study its impact on those statistics. So the power spectrum, which we define like this, so delta K is the Fourier transform of the signal fluctuations. And let's see if we want to cross-correlate the fluctuations between these two signals, that is the C2 and 21 centimeter signals from EoR. So we do it like this, and then see what it looks like. So what we did here is that we take out Lightcone cubes, we simulate Lightcone box, and using Lightcone cubes, we see its impact on the statistics. So what we find is that for the auto power spectrum, the Lightcone might significantly affect the C2 power spectrum. So for certain redshifts, the change can be as high as 15% and go beyond that for large length scales. And for the cross-power spectrum, we see that the Lightcone impact drastically varies for different reionization histories that we might consider. So in this panel, we can see the change in the cross-power spectrum, and we see that this statistic also gets quite largely impacted. So it's beyond 20%, depending on what kind of redshifts or neutral fractions we are dealing with. So all in all, what we conclude is that we need to take this Lightcone impact into account if we are to use these statistics to constrain the reaction parameters. So if you are interested, you can read more about it in this paper. And with this, I leave you, and thank you very much for your time.